Hi everybody and welcome to a new episode of Diagnose Dan. Today we are working on a 2014 Mitsubishi Outlander Hybrid. Now this vehicle was parked in front of one of our customers' homes. When they push the start button, normally on a petrol version the engine will start to crank and hopefully the engine will start. But on a hybrid or an electric vehicle, when you push the start button, the car will tell you it's ready. Now when you push the start button on this car, the ready sign doesn't come up and there is a message on the dash telling us there's something wrong with the high voltage system. Now this car was brought on a flatbed to our shop and we noticed the high voltage battery was totally empty. Now we tried to charge it, but the battery won't accept a charge. Now since there aren't a lot of videos diagnosing hybrid and electric vehicles on the internet yet, I thought it might be interesting to take you along diagnosing this car. So let's diagnose this together. I took the opportunity and walked outside my shop where a similar Outlander is parked for regular maintenance. I want to show you that when I hit the start button, the ready light will come on and the car is ready to drive. We're back inside the shop. Inside the car we're about to diagnose. Now when I hit the start button on this one, notice there is no ready light. We've also got messages in the dash telling us there's something wrong with the high voltage system. You can also see the high voltage battery is totally empty. Now we tried to charge it, but the battery won't accept a charge. I hooked up the scan tool and I did a full system scan of this car. And there is a code stored in the BMU. The BMU, or Battery Management Unit, is responsible for everything involving the high voltage battery. Now let's go into the Battery Management Unit and let's read the codes. And there is a fault code stored, P1 AAD, battery current sensor fail, CAN, active DTC. We've got a fault code stored in our BMU for the battery current sensor. The battery current sensor is responsible for measuring the current going into the battery, for example while it's being charged, and the current going out of the battery while it's powering the high voltage systems. Now, without the information from the current sensor, the BMU doesn't know how much current is going into and getting out of the battery, so it can't operate properly. So this explains why our high voltage battery is no longer accepting a charge. Now also notice that the word CAN is in the fault code description. Now let's take a look at a wiring diagram to get a better understanding why the word CAN is in the fault code. This is a part of the wiring diagram for the inside of our high voltage battery. Placed inside the high voltage battery is the current sensor. Placed outside the high voltage battery is the BMU, or Battery Management Unit. This is the unit that's flagging a code for the current sensor. As you can see, the current sensor is a 4-wire sensor. We've got a red power feed, a white and light green communication wire, and a black ground wire. Let's take a closer look at the 4 wires. Let's start out with the red power supply. As you can see, the power supply is being shared internally between the ground fault detector and the current sensor. The BMU is not flagging a code for the ground fault detector, so we can assume this sensor is working just fine. Now if this sensor is working, this means the power supply is making it into the battery. Now just for peace of mind, I checked the light green wire at pin 2 just outside the battery with the test light, and sure enough, we had a good voltage supply. Now this doesn't mean the voltage supply makes it all the way to our current sensor, but there is no way of telling without opening the battery. These are the two communication wires that run between the BMU and the high voltage battery. Now the BMU is receiving information from each of these modules, just not from the current sensor. So we know the BMU is able to communicate with all these modules, so there's nothing wrong with the network inside the battery. Now we don't know if the communication is making it all the way to the current sensor, but there is no way of telling this without measuring at the current sensor itself. To do that, the battery needs to be opened. The fourth and final wire is this black ground wire going to the current sensor. You can see it's being shared internally with all the other modules. So we know the ground going into the battery is just fine. Now again, we don't know if the ground is making it all the way to the current sensor. For all we know, there could be a loose connector. Now, unfortunately, there is no way of diagnosing this sensor without removing and opening up the battery and do the measurements at the sensor itself. Since the current sensor is located inside the high voltage battery, we've got no choice than to remove the high voltage battery from underneath the vehicle, open it up to see what's going on. Now, working on high voltage systems can be dangerous. So when doing so, make sure you've got the right paperwork. Make sure you're an EV qualified technician. And also always follow the rules and regulations in your country. Before we start removing and opening the battery pack from our Outlander to see what's wrong, please be aware I did a 3-video series on hybrid electric high voltage batteries. In these 3 videos, we open up an Outlander high voltage battery and go through each and every component in great detail. After watching these 3 videos, you will have a detailed understanding of what's going on inside a high voltage battery. We also talk about your personal safety and the safety of others while working on high voltage systems. So if you want to learn more, don't forget to watch these 3 videos. Now if you like free tools, and who doesn't, please pay attention. In this video, we're doing another giveaway. And to be honest, it's one of the best giveaways we've done on this channel so far. We're giving away the Dytex AutoSim Pro Master Kit. Now the AutoSim Pro is a state-of-the-art sensor simulator, which is a great tool just by itself. But this Master Kit includes every accessory a professional diagnostician could ever dream of. If you want to win this tool, all you have to do is leave a comment in the comment section of this video, and in the next video we'll randomly pick a winner. So let's start removing and opening up the battery pack of our Outlander. Now please keep in mind that working on high voltage systems is potentially dangerous, and always follow the rules and regulations in your country. Now the whole process of removing and opening up the battery pack is quite a lengthy one. So I take short clips of what I'm doing to speed up the process. Now one tip before we begin, most battery packs on hybrid and electric vehicles are mounted underneath the vehicle. So make sure you don't damage the battery pack while putting the car up on a lift. Now that we've got the battery pack out from underneath the car and opened it up, we can take a look inside and try to find out what's wrong. Now what I did is reconnect the low voltage connectors from the car to the battery pack. So right now we've got a live working high voltage battery pack. In order to do that, I needed to reconnect the 12-volt battery. Now you might wonder, isn't that dangerous? And yeah, that's dangerous. But is it more dangerous than it was before? Over here we got an opened up exposed high voltage battery. Now no matter these connectors are connected or disconnected, the high voltage is still gonna be there. So it's gonna be dangerous no matter what. Now the rest of the car, these high voltage wires, the motor, the inverter, they are safe to work on. But the high voltage battery is always gonna be high voltage, so take care. Now, you might wonder, if I'm wearing these insulated high voltage gloves to protect me against the shock, why do I still need to use insulated tools? Now think about it. When you're working above an opened up, exposed high voltage battery and you drop a regular wrench, it's going to short out the battery and it might start a fire. That's why you use insulated tools. If you drop these ones, nothing's going to happen. Now the current sensor inside this battery is a 4-wire sensor. In the next step, I want to check the power, the ground, and both communication wires. The red and the black wire are our power and our ground. What I did is back probe the ground wire, the black wire, attach a piece of wire to it, which I connected to one side of my test light. Now, when I touch the red wire with the other side of the test light, if the power and ground are good, the test light should light up. And as you can see, the test light lights up, so the power and the ground are fine. Now, as you can see, this blue piece over here is a high voltage bus bar, so you can see how close we are working to the high voltage system. We took a look at our power and ground, and that was not our issue. Now we've got 2 wires left, a light green and a white wire, which are our CAN high and CAN low communication wires. Right now, I've got the scope hooked up to those 2 wires, so let's see what the communication looks like. I've got 2 channels back probed to the CAN high and CAN low wire of our current sensor. Now let's take a look at the communication that's going on our network. And as you can see, there seems to be absolutely no issue with the communication on our network. We've got good ground, good power, and good communication. Everything is there for a sensor to work properly, but it doesn't, so my final diagnosis is we've got a bad current sensor. Now this is a new one. It basically works the same as an amp clamp. It's being placed over a high voltage cable or bus bar, and it measures the amount of current that goes through it. It's responsible for measuring all the current going into and out of our battery pack. The battery management computer needs this information to manage the charging and discharging of the pack. Without the information from this sensor, it flags a code and it no longer accepts a charge. Since it's quite a lot of work to install the sensor, close the battery, and replace it under the car again, we want to be 100% sure we fixed the issue. So we're going to do a little test. We're going to read the fault codes with the old sensor still installed and try to clear it. After that, we're going to hook up the new sensor, read and clear again, and see what happens. Right now we're inside the battery management unit. So let's read the codes, and sure enough, we've got a fault code stored for a battery current sensor. Now let's go back and let's try and clear the codes. Let's read again. And as you can see, our fault code is still there. Now just to be 100% sure, let's try a second time. Let's clear the codes. Let's read again. And still, our code hasn't cleared. I disconnected the connector from the old sensor and I'm going to hook it up to the new one, just to confirm we made the right call before installing it. Now this component is a low voltage component, but still I'm wearing high voltage gloves. This is because I'm working close to high voltage components, and when I don't pay attention or when I trip and put my hand on the battery, I could be in serious trouble. Let's read the fault codes again. And this time we've got 3 codes stored. Now this is because of me disconnecting the connector and installing the new sensor. So basically we can ignore the extra codes. But the big question is, will the codes clear this time with the new sensor installed? So let's go back, clear the codes, and let's read again. And as you can see, no codes present. So we made the right call. This battery pack had a bad current sensor. So we made the right call, a bad current sensor. Now I'm gonna install the current sensor, close the battery, and reinstall the battery in the car again. I'm not gonna film it. It's basically the reversed order of the clip you saw earlier. If you want more detail of where the current sensor is located and how the battery pack operates, I advise you to watch one of my other 3 videos I made on a similar battery pack. I recently started a new Facebook group called the Diagnose Global Tech Support Group. I started this group because I was getting too many technical questions to answer by myself. So a lot of questions stayed unanswered, and I don't think that's fair to you guys. In this group are some of the best technicians from all around the world. You can ask your questions there, and on your turn, you can use your expertise to help others. So if you want to learn more, share knowledge, and help others, please consider joining the Diagnose Global Tech Support Facebook group. Let's diagnose it together. The battery pack is reinstalled, and I had to leave the car charging for a while because the battery pack was totally empty. Now the great news is that it's accepting a charge again. But the big question is the car ready to drive again? So let's find out. The moment of truth, new current sensor installed. Let's hit the power button, and it looks like the car is ready to go. The battery is accepting a charge again, and also very important, no more warning messages on our dash. We just diagnosed and fixed a hybrid electric vehicle. Cool, right? Now, if you want to learn more about hybrid electric vehicles and how they operate, don't forget to watch my other videos on the subject. If you want a chance on winning that fantastic AutoSim Pro Master Kit, leave a comment in the comment section and the winner will be picked in the next video. Also, consider joining the new Facebook group, and always remember, Diagnose Dan, fix it again. See you next time, guys. The reason I started this group is because I'm getting too many testicles. I recently started a new Facebook group. The name of this group is the Diagnose Gland. We took a look at the power and the ground, and that was not our issue. Right now I've got the scope hooked up to the light green and white wire, which are the CAN high and the CLAN.